And so this is the 4.7 or 8 to 4.13 quiz, I think. I forgot the numbers of the chapters or whatever. Okay, so let's solve. This group of students investigating law of moments, which means moment clockwise equals moment counterclockwise, and they have a uniform meter stick. So uniform meaning its center of gravity is in the middle, and the fulcrum suspends two masses, mass 1 and mass 2, and is always located. Oh yeah, so mass 1 is 200, so this is 200 grams, and it's located 30 centimeters away. And this, we don't know it, but it's also gonna be, they are varying, and we just need to keep the meter stick horizontal. So what we do here is we have to do, we need to see the combinations of mass 2 and D to balance the stick. If you have, first we need to find the moments of the, what's it called? This is counterclockwise. So the moment of the counterclockwise we know is 30 times 200 times 10. Or wait, no, sorry, not 30 nor 200, because we need to take them in meters and in kilograms. So 0.3 times 0.2 times 10 is gonna give us, let me get my calculator. Yeah, so 0.3 times 0.2 times 10 is gonna give us 0.6. So now we need to see these combinations, which one is gonna give us 0.6. So 150 and 40. 150 grams, which is 0.15. So 0.15. 40 centimeters times 0.4 times 10 is gonna give us 0.6. So this is right. 600 grams and 10 centimeters away. So we do 600, which is 0.6, times 0.1 times 10 is also gonna give us 0.6 when you put it in your calculator, which is correct. Now let's go on to the other options. 50 grams, which is 0.05 times 0.45 times 10. Let's solve it really quickly. Equals 0.225, which is not 0.6, so it's wrong. Now 1200 grams, which is 1.2 times 0.05 times 10 is gonna give us 0.6, and this, which is 1.5 times 0.02 times 10, gives us 1.5 times 0.02 times 10 gives us 0.3, which is not 0.6, so it is wrong. So this, and this are the only three that give us 0.6. So these are the only correct three. Now let's move on to the next question. Now, next question is asking us, telling us we have a uniform square box of weight 16 newtons and side 40 centimeters sat on a horizontal rough floor. The cross section of the box is shown in the diagram below. The person wants to flip the box over by applying a vertical force on the handle of the box located 35 above its base. So now we know that they want you to see what forces are gonna produce a non-zero torque. So which are gonna actually produce a torque. So we know that our fulcrum is here, and we know that we have tension acting upwards, and we have friction acting this way, and then we have we have the normal also acting upwards. So these three forces, as we can see, are all running through the fulcrum. When we see any force running through the fulcrum, immediately, it's zero. So we do not consider it. See? And, oh yeah, upthrust. Upthrust is the same thing as normal, so it's going up, whatever. But now you have weight, which is here, and force F, which is here. They're both not passing through the fulcrum, so they will both produce a torque. And yeah, that's how you get these answers. Now, the smallest magnitude of F that can topple the box is... So, we know that you need a force F that topples the box. And for it to topple the box, it should produce... So, force F should produce a force bigger than the force of the weight. Or like bigger than the torque of the weight. So, bigger than weight moment. So to do this, we need to calculate the weight's moment and we need to make F bigger than it. So we know our weight is the moment of our weight, and we know moment equals the force times distance. So now let's see the weight. So we have a weight of 60 newtons. They gave us this. And we know it's at a distance of 20 because it's half 40. So 60 newtons times 20 has to be less than, or you need to produce a force bigger than. Now we need to find the F. So the distance of F is 40 centimeters away from your fulcrum. Here it was 20 and here it's 40. So since it's 40 centimeters away from our fulcrum, we need to find a force that's 40 the distance times the force that is bigger than this. So it's gonna be 40 times F bigger than 120. So the force F has to be at least 30 for it to topple. See, it's bigger than or equal to 120. Force F has to be 30. That is your minimum. So we know that the moment of force F has to be bigger than or equal, or well, bigger than weight, the moment of the weight. So we find the moment of the weight and we find the moment of force F. And then we find the distance that makes it equal, and that is your minimum force that you could have to topple the box over. Now let's see, it's 30. It's the smallest, and magnitude since it's positive since it's magnitude. So now let's move on to the next one. You have a massless seesaw. So you have a seesaw that has no mass at length 100 centimeters. So this is 100 centimeters and it has two people sitting. You have a person here that is 40 kilograms and you have a person here that is 60 kilograms. Now we need to find the center of the gravity and how far away from 40 it is, or the 40 kilogram person it is. Since this is 100, all of it, we need to know that there's a law that says mass 1, this is 1, over mass 2 equals GG2 over GG1. So we need to find our ratios first. So our ratio of this is 40 over 60 equals GG2 over GG1. And guys, by the way, this is only for these aren't formulas or anything. These are, well, they are formulas, but they're ratios. You're only using the ratio out of this. So first we find this simplified. It's gonna be 2 over 3. That's your ratio. So GG2 over GG1 is 3 over 2. But we're gonna use this later. So since this is your ratio and we know that the whole thing is 100 centimeters, we're gonna use it. So 2x plus 3x gives us 100 centimeters. 5x equals 100. So x has to equal to 20. Since x equals 20, now we know that for the 40 kilogram person, your ratios for the, for the distance is opposite. So it's 3/2 for the GG2 and GG1. But now you have to multiply these by the 20 times 20 times 20, because you need to find distance, and this is your x, and we know that it's weight times distance. So this, by the way, is corresponding to the 40, and this is corresponding to the 60. We just have to put this as a disclaimer. Yeah. So now let's see. 3 times 20 is 60, and this is 40. So the 40 kilogram person has to sit, let me change the color. The 40 kilogram person has to sit 60 centimeters away, and the 60 kilogram person has to sit 40 centimeters away from the fulcrum. So when you put your fulcrum, here there has to be 60, here there has to be 40 centimeters. That's how you calculate the first one. Now for part B, they want the force exerted by the fulcrum of the seesaw. We have the seesaw is massless, it has no mass. So all we know is we have weight acting here, that the seesaw has to resist it. So we'll find the weight. So since here you have a 40 kilogram person, you multiply it by 10 to find weight, because W equals mg. So here you have 400, and here you have 60 kilograms times 10, 600. So now this, since it's resisting these two, you're gonna do 400 plus 600 gives you 1000, and that's your answer. That is it. Now let's move on to the next part. Okay, so here you have a uniform square lamina shown in the diagram below. C and E are midpoints of the sides of the square, and the lamina is suspended from point A and allowed to hang freely. So since this is a uniform square ladder, we know that its center is the geometric center, which is B. So if you hang it from point A, it's gonna pass through B always, because B is your center of gravity. So here you're hanging it from A, and it's gonna pass like that. So since you're hanging it from A, you're gonna, if you want, try redrawing it. A, then you'll have B here, and then you'll have F here, and probably C here, and this is A. Then here you'd have E, and here you'd have D. If you draw this and you connect a line, the vertical line is passing through these 2 points. See which of the segments will be vertical. The options didn't have BF, so you don't choose it. So AB is your answer. Now let's see part B. The weight of the lamina is 20 grams and the side of the square is 10 centimeters. The moment of the weight of the lamina as it hangs freely is... Now, we would solve this, but we know that weight acts downwards, and this is the weight of the lamina. Wait, let me redraw that. So it acts downwards, the weight of the lamina, or weight in general acts downwards. It's downwards to A, so it's gonna pass through A and B and F. Since it's passing through A, and we know that our fulcrum is A, it's passing through our fulcrum, so the weight is gonna be 0, because anything passing through the fulcrum is 0. Now let's go to the next question. Okay, this question is telling you that you have a group of students investigating law of moments. They put a uniform meter stick on a fulcrum and suspend 2 masses from it. Fulcrum is at the center, and one of the weights is attached is equal to 2 newtons. The other weight is unknown. So here we have a graph. They're telling us these is the forces that keep this rod balanced. So when we get a graph, we use the graph to see. So first you'll have to do 1.15 divided 0.1. So 0.15 divided by 0.1 equals 1.5, and that's how you get the slope of the graph. Now we use a slope usually as a I forgot what it's called. We use it as your equation, kind of. I forgot what it's called. Your constant. Yeah, you use it as a constant. So if you had a known weight 2 and your constant to keep it balanced is 1.5, so you multiply the 2 by 1.5, you're gonna get 3, which means your other weight should be 3 if you want to keep it balanced if one of them is 2. Let's say your other weight was 5, then you'd replace this 2 with a 5, and so on. So let's move on to the next one. Okay, so this question is telling us we have a group of students. They're investigating the law of moments and they suspend a uniform meter stick from the fulcrum, placed 70 centimeters away from one of its ends. Then they try to keep it balanced. We know this is a uniform meter stick. So if it's a uniform meter stick, the fulcrum should be here or like in the middle. So meaning here should be 50 and here should be 50. But since it's not like this and they played with it, let's say we need to calculate the torque with an extension. If this is 70 and the normal, what it should be, or like the geometrical center is 50, the extension we had, which is this distance here, is 20 centimeters. Now we have to solve our torque using that 20 centimeters. So we need to find what force do you put here, I think. Wait, let's see. Okay, by law of moments, the meter stick remains equilibrium. The fulcrum must be equal to the torque of the meter stick's weight, which is, yeah, you're using the meter stick's weight to balance out this. If the meter stick is uniform, then the mass of the stick. So we need to use the clockwise, moments clockwise equals moments counterclockwise. So for our moment clockwise, we said we do the extension, or how much it's away from the 50, times the force. We don't know our force yet, I think. Yeah, we don't know our force yet for this side. So it's 20 times force equals the distance and the weights. They gave us any point, we can use it, 11 and 10. They're all going to give you the same answer, by the way. So it's equal to 110. We're going to use 11 and 10, okay? Because it's direct and you don't need a calculator for it. When you do this, you're going to find that F equals 5.5. So that is our force in newtons. We know newtons is kilogram per meter. Or wait, is it? We know newtons is in kilograms and G. It's weight, force equals weight times distance. شو دخل kilograms? Wait, guys. Force equals mass times acceleration, sorry. So newtons is in kilograms, we know this already. So what we do to this is we need to find the kilogram, we need to find it in grams. So first we need to find the weight. So this is a force and F equals MA. So F is 5.5 equals M times A. A is 10, as they gave us. So now we know 5.5 divided by 10, which is 0.55 equals mass. So this is in kilograms. So I'm going to replace the mass here by kg. They want it in grams. So you multiply it times 10 power 3. You're going to get it to be 550. And that's how you get your mass for the second part. See, 550. Okay, for this question, it's telling you have a uniform plank that's length is 100 centimeters. So its length is 100 centimeters. This is 100. Meaning half of it, since it's uniform, is 50. Let me change the color. So this is 50 and the blue is 100. Now we need to find the moments. So using it, moments clockwise equals moments counterclockwise. Wait, this is the same thing. Counterclockwise. Now we're taking our forces to be about, oh no, what did I do? So this is 100 and this is 50, and we're taking moments clockwise equals moments counterclockwise, which is like that. So you're taking the moment about point A, and you need to find the tension. The tension here is your force, and it's upward force. Tension is always an upward force. So we need to find the weight. There's a weight acting on it. So we need to find the moment of the weight, which our weight is 30 newtons. So 30 newtons, and we know that this is an inclined plane, so we have an angle. So the moment equals the weight times distance times cosine of your angle, which is 37. Now let's replace parts of the given. Distance is 50. Weight is 30. So once you do this in your calculator, you're gonna get, let me do it really quickly, 30 times 50 times cosine 37. You're gonna get it to be moment equals 1198. We're gonna round it up to 98. Now, knowing this, we need the other. This is your moments. This is your moment clockwise. Now this is your moment counterclockwise. So we need this to equal this. So this is just tension times 100, which is your distance, times cosine 37 again, equals to 1198. So when you do it in your calculator, which we do 1198 over 100 times cosine 37, put that in your calculator and let's see what we get. 1198 divided by 100 times cosine 37. You're gonna get it to be equal to 15.00058, but we're gonna round it up to 15, and that is our answer over here. So that's how you get the tension. Now we know that normal reaction usually is 0, but normal reaction has a force. It doesn't not have a force. It has a force, but it's usually 0 because it's cancelling out with another force, or it's gonna be like this. So the cosine of it is gonna be 180, and 180's cosine is 0, making anything else 0. So the magnitude of the normal reaction is, so let's see, we could just do the forces down, all of them are equal to the forces up. So our forces up are tension, and our forces down are weight. So our weight is 30 newtons, and our forces up is 15, we just found it. So your normal force plus 15 is gonna equal to 30. Or well, like, you could just do, yeah, because normal is gonna be upwards, so that's why you add it with the 15. So x equals 15. So you're gonna do all your forces up, which is 15, and the normal reaction equals all the forces down, which is 30. So x plus 15 equals 30. That's it. So yeah, that's it for this question. They're telling us we have a non-uniform plank. So it's just any plank that's a length of 400. So let's see. This length is 400, and it's held horizontally by 2 vertical cords. The tension here is 500, tension here is 300. So they're asking us the mass of the plank. What we do is we have to do, wait, what do we have to do? So the mass is gonna be the upward force on the cable, so the upward force. So you're just gonna add your forces here, which is 500 plus 300, which is gonna be 800. That is your force, it's in newtons. Now we know force equals mass times mg. So our g is 10, our mass is x, or well m, and our force equals 800. So m equals 80 kilograms, as we could see. Now, to find the center of the mass, we're gonna have to calculate clockwise moments equals counterclockwise moments. So what we do is, okay, so 500 times distance x, so 500x equals 300 times distance 400 minus x. So we're gonna expand this. 500x equals 1, 2, 1, 2, 3, 4 minus 300x. So you're gonna move this to this side, gonna be left with 800x equals 1, 2, 1, 2, 3, 4. So x is gonna equal 150, and it is 150 away from the 500. If you wanted it how much is away from for 300, you could do this and subtract this from 450, or you could just give the x here and 400 minus x here if they asked you for distance from 300, but they didn't, so you do this. Okay, so this person is standing on a uniform diving board of length 2 meters, and the mass of the person is 50 kilograms, and he's standing 1.2 meters away from the point where the diving board is attached to the stand. If the diving board is at equilibrium, and what I know is that if it's in equilibrium, net force and net torque are always gonna equal 0. That's what I know. So net force and net torque when it's at equilibrium is 0. Let's move on to the next one. You have a solid wooden block and it's placed on the ground. The dots represent the centers of the gravity of the block parts. We're gonna see why the block is not gonna fall over. Well, we're gonna solve it. The block will not fall over. Why will it not fall over? Because the vertical line through the center of gravity intersects its baseline. If it intersects the baseline, they're not gonna tumble over. As you can see, they both will intersect their baseline, so it will not tumble over. But let's say you had this weird object. Well, no, let's make it more weird. And the center of gravity was here. Baseline was here, let's say. And this, if it's like this and it doesn't pass through the baseline, it will tumble over. So that's it. Okay. Now you have a toy tower crane, and it's made of a uniform column C of mass 800 grams and width 4 centimeters. The massless rod of length 40 and the weight W can move along the rod as shown in the diagram below. The center of gravity is column C is the midpoint of the column. This is your center of gravity. And it's at the same height of W. So they're at the same height. So now what we have to do to find part A, they're asking you when the weight attached to the crane, it moves away from the column. The crane weight system will topple when the gravity of the system moves horizontally more than. Remember what we said last question where it has to intersect with your baseline? If you move it any more than this distance, it's gonna topple over. So this is the maximum distance before it will not stop intersecting with our baseline. So this distance here is gonna be half of the 4 centimeters, which is 2 centimeters. Let's move on to the next part. The maximum distance that the weight can move without toppling the crane is. So what we have to do for this part is clockwise moments equals counterclockwise moments. So, sorry, you're gonna find the clockwise moment of the. Wait, what's the center of gravity? Oh, C. So we're gonna do 800 grams times the 2 that we need before it topples over. This is your distance. Equals to W times 50, or well, 50 times X, which is your distance. 50 times X. So we get this by 1600 equals 50x. X will equal to 32. That is it. And let's move on to the next question. Okay, so we said baselines must intersect here. So here it's intersecting, here it's intersecting, here it's intersecting, here it does not intersect this baseline. It intersects baseline, intersects baseline, intersects baseline. This is the only one that does not intersect your baseline, so it is unstable. That is it. Now last question. Okay, this question is involving equilibrium. It's really easy. Clockwise moments equals counterclockwise moments. So here you have your distance and here you have your force. So we know that this moment, which is your counterclockwise moment, is equal to 50 times 25, which is, let me do it in my calculator. Shouldn't it be in? No, it's fine. So it's gonna be 1250. And now we need the force equals to 40 times x, sorry. So, well, let me write x like a different way, x. So once you do this in your calculator, you're gonna find x to be 31.25. They want it to the closest number, so just 31. Now the upward force exerted by the fulcrum on the plank. Let's see. So we know that the weight of the bar here is 20 newtons. So this thing's weight is 20 newtons. And we know that this is 31. Now let's calculate all our forces acting downwards so we could move it upwards, or like we need the upwards, which is resisting the downward forces. So 50 plus 31 plus 20, it's gonna give us 101 exactly. So that is it, and that's the end of our chapters 4 point whatever to 4.13 quiz. I hope you understood everything. If you have any questions, leave them in the comments. Bye. Hope you have a nice day.